This video will present the Bachelor semester project of Adriano Viegas Milani, made with the assistance of Jean Botev for the 5th semester of the Bachelor in Computer Science at the University of Luxembourg. This project, as well as this video, have two main objectives. The first is a presentation on immersion and virtual reality. The second is the creation of an updated version of the immersive VR series game, SaVR, presented previously for another project. But before talking about them, let's first explain why they were produced. Virtual reality, despite still being a small area of technology, is becoming more and more common. The number of consumer headsets sold in 2020 is predicted to be 6.4 million units. In the previous project, we made SaVR, a virtual reality series game about deforestation. While it satisfied our defined requirements, and I'm pretty happy about it, there are many aspects which could be enhanced. Our objective is to increase awareness about climate change and deforestation, and yet out of the millions of VR users, only about 10 actually experienced it. The reason being that it simply isn't available anywhere, and rightfully so, as it wasn't really a finished product. So in this project we will attempt to create a new version of SaVR closer to a finished serious game. One of the areas of focus is to make it more immersive and informative. In order to do so, we first need to understand what immersion is, and how do we increase it. And so, this video is separated into parts, scientific and technical. The scientific domains of this video are virtual reality, serious games, and immersion. Them being scientific doesn't mean they only affect the scientific part. On the contrary, the domain of serious games is mainly touched upon in the technical part. The technical domains are virtual reality development and computer graphics. Previously, we defined what VR and serious games were: a real or simulated environment in which a perceiver experiences artificial presence, and any piece of software that merges a non-entertaining purpose with a video game structure. We also used Unity and C# for the development of SaVR, so these are the prerequisites for this time. Without further ado, let's talk about immersion. Immersion is a commonly used word when describing books, video games, virtual reality experience, or even theater plays. However, the overuse of this word has made it a vague concept. Before attempting to find a single definition, we need to question the possible existence of different types of immersion. Is immersion driven by a book different from immersion in a video game? One such view, held by Slater, is that immersion is an objective concept related only to the technology. Using this definition of immersion, virtual reality would be the most immersive and books the least, entirely ignoring the human perspective. A more commonly accepted idea is that immersion is a psychological state of an individual. Agrawal et al. Summarize the different reasons that could lead to immersion in this figure. On the right we can see the view given before, of immersion being objective. On the left we have psychological immersion. There are three main reasons which can lead to psychological immersion. The first is the subjective sense of being surrounded or experiencing multisensory stimulation. It is dubbed the perceptual immersion and is closer to an objective property, as it is believed that it can be measured by counting the number of senses of the user that are overwritten by the experience or technology. However, it is still considered a reason for the psychological immersion of an individual, as instead of attracting the user's attention to the content, it tries to limit the possible distractions. This creates a subjective experience of being enveloped by the virtual environment. Virtual reality attempts to achieve the best possible perceptual immersion. The second reason is absorption in the narrative, or the depiction of the narrative. It focuses on the narrative aspect of an experience, that is, the engagement of the user in the story. Narrative immersion is categorized in spatial, temporal, and emotional immersion. Spatial is due to the environmental world, temporal is the story or plot, and emotional is due to the characters. The third reason is the absorption when facing strategic and/or tactical challenges. As opposed to the previous category, which focuses on the narrative, it is not applicable to narrative-only entertainment, such as books or movies, but only on physical games or video games. Tactical immersion is defined as the focused attention of a user on a task due to continued and rapid demand of action. Strategic immersion, in the contrary, is the focused attention of a user in calculations, making choices and creation of strategies. An alternative version, proposed by Arsenal, systematic immersion, states that systematic immersion happens when a user accepts the rules and laws of the game, replacing the ones of real life, such as the concept of health points in some games. Agrawal et al. Also produced their proposition for a generalized definition of immersion. Immersion is a phenomenon experienced by an individual when they are in a state of deep mental involvement in which their cognitive processes, with or without sensory stimulation, cause a shift in their attentional state such that one may experience disassociation from the awareness of the physical world. This is the definition chosen for this video. Agrawal et al. Identified two major categories of attempts at measuring immersion. The first category is questionnaires. They are the simplest and most common form of measurement, but also suffer from possible inaccuracies. The second category are physiological and behavioral measures. They attempt to be more objective than questionnaires by measuring easily quantifiable data, such as the lack of awareness of the real environment or eye movement. The big problem of this solution is that the link between some data and immersion is not well established. One main benefit of immersion can be taken from its definition. The user becomes deeply mentally involved with the immersive activity, and thus, higher immersion means higher focus. Different studies have shown benefits of immersion for multiple situations and objectives, like for psychological studies, education, and raising awareness. In order to increase user immersion in an application, it is necessary to increase the reasons which cause immersion. The first is quite difficult to increase since it's more linked with the system used rather than a specific application. In VR, the application just needs to fully use all of the features proposed with audio, screen, and tracking, and also under 20 milliseconds of reaction time. The second, narrative immersion, can be increased through many ways for a VR application. Basically by creating a better, more attaching story, characters, and world, but also with higher quality graphics and better artistic visuals. The third can be increased by having interaction with the environment for VR apps, but in general, rules and principles of game design should still be respected for increased systematic immersion. This concludes our short presentation on immersion in virtual reality. Now let's talk about Forest Saver 0.2. Based on the original Forest Saver, we define a list of requirements for this new version. It should be usable in VR, increase awareness about deforestation, be immersive, realistic, and interactive. So, firstly, it is developed with Unity, as with version 1, but this time we want to make it compatible with as many platforms as possible. Using Unity's XR plugin management, we can effortlessly make the application work for the entire Oculus and Windows mixed reality platforms. SteamVR, which includes platforms such as Vive and Valve, is not yet implemented with this plugin, but it is in development and will be coming soon. The first version of this project had a progress concept, where the user could pass from each state of the forest to another, more destroyed state. Forest Saver 0.2 has the same objective as the first version, but also being a bit more informative. The serious game consists of a 5-minute experience where the user can visit various points of interest, situated in the healthy, which is the main, state of the forest. Each point of interest would treat a subject categorized as farming, fire, pests and pathogens, and erosion. Within a point of interest, the user can travel to other more destroyed states of the forest through portals, which are activated with keys that represent the destination state. Lighting is really important to make a realistic environment. Previously, we used Aurora 2, a commercial volumetric lighting fog solution for Unity. For this version, we chose to use Unity's high-definition rendering pipeline. HDRP is a scriptable rendering pipeline. This is the new technology replacing the standard renderer of the Unity game engine. Unity provides two predefined scriptable pipelines, HDRP and the Universal Render Pipeline. While HDRP is more resource-intensive than the standard renderer pipeline or even URP, it offers more tools to create high-fidelity environments, especially in the lighting area. For lower-end devices or more stylized games, it is suggested to use URP. Most of the issues encountered when testing HDRP with virtual reality for the first version have been fixed in the chosen Unity version, which is 2020.2. This is the result when we add volumetric lighting and fog with HDRP. For Forest Saver 0.2, we opted for a commercial asset pack named Forest Environment Dynamic Nature by Nature Manufacture for all of the vegetation, including the trees. The environment was built with nearly the same techniques as for the first version, using the tree-instantiator C# class. One modification is that now, before placing each tree, we do a raycast to see if there is anything blocking the way. This way, we can create empty areas wherever we want, and there is less clipping of objects. We also use the same environment sound system as before, so each state has environmental sound, but no localized sources. To create the portals, we used Shadergraph, a Unity tool to visually create shaders. Shaders are basically functions which affect each pixel of a texture in an optimized way, usually through the GPU. This results in them showing an image of the destination state with a parallax effect, as well as having a white border and a little twirl effect. For the application to be compatible with the chosen platforms, we used Unity's solution for VR implementation. With the XR interaction toolkit, we can get a joystick locomotion, snap turning, and even an interaction system that are independent of the platform, so it works everywhere. This interaction system is used to grab objects with the user's virtual hands. These hands were made using animations and a model from Oculus, but are implemented in a way so that they work with any controller. The idea is for the hand to somewhat mimic the user's real hands. To activate the portals, users have to place the keys on a pedestal. The pedestal constantly looks around for what is in its area, and when it gets an ungrabbed key, it will activate the corresponding portal, which the user can then enter. They will then appear in an altered state, but their position and rotation is kept, so if you enter the portal from the back, you will get out from the front and vice versa. In conclusion, we attempted to create a new version of our SaVR. The objective was to increase awareness through a more immersive and informative serious game. In the end, the resulting deliverable does not attain the defined objectives. It cannot be considered a finished serious game. The performance is quite terrible, having an average of 20 to 30 frames per second. We only have 4 states and 2 points of interest when we wanted to have at least 4 points of interest, and we didn't manage to find a way to give more information without breaking immersion. So in the end we don't add any extra information at all. Still, this is an ongoing project, and this version was more focused on the foundation and is a basis for further work. We managed to have a basic interaction system, we have a way to transition from the states and have a somewhat beautiful environment, although it has some weird parts. Now, for the next version, we need to make a lot of things better, such as increasing the interaction, finding a way to display information about deforestation issues without interfering with immersion, and adding more states. Whether this next attempt will be a success or not, well, we'll see in the next video. And that's all for this video. Thank you very much for watching, and if you want more information about the project, please refer to the full paper.